Hello everybody, today we'll be transitioning away from triangles into circles. So the technical definition of a circle is the collection of points that are equidistant from one point. So let's find all the points that are 1 centimeter away from this point. This point is 1 centimeter away, this point's 1 centimeter away, this point's 1 centimeter away, this point's 1 centimeter away. All these points are 1 centimeter away. And if you see, if we keep drawing every single dot, we do end up with a circle, right? So all these points, even though my picture doesn't make it look like it, are the same distance away from that center, because that's the definition of a circle, right? And that distance that we talked about, if we remember, from here to here, that is our radius. And then all the way across through the center is going to be the diameter. And as you can tell, this diameter is just 2 radius combined, right? So you can just remember it's twice as big as the radius, or some people like equations, 2 times radius, whatever. Just know the diameter is twice as big. And then we know that the perimeter of a circle, that is called the circumference. And then we also have the area, which is everything on the inside. Area. So we do have an equation for the circumference, though for the perimeter, because we can't just measure it with the ruler. Our equation is c equals pi times diameter. So let's go ahead and find the circumference of this circle if the radius is just 2 centimeters. So since it's circumference, c equals pi times diameter, we're using c variable and we're using the diameter variable. It does not give us a circumference, that's what we have to find, so we'll just leave it as c. Our pi, that is the variable we use with circles, which equals 3.14, but we're just going to leave it as pi. And then our diameter, it only gives us the radius, but we can just multiply this by 2 to get a diameter of 4. So we have c equals 4 pi centimeters. And then remember, pi is 3.14, so we can do 4 times 3.14. And when we do 4 times 3.14, let's see what we get. And we get 12.56, so equals 12.56 centimeters. So those are your two answers, 4 pi or 12.56, but just so we don't have to keep plugging it in, we're going to leave our answers with pi. So 4 pi is what we're going to leave it as. Okay, and so for this one, we want to find the diameter this time if we're given the circumference. So nothing changes, right? We're still using this variable, still using this variable, and so this time it gives us our circumference of 30 pi, so we'll put that in the C spot, 30 pi times, and then our diameter, right? That's what we need to find, so we're just going to leave that as d. We solve for the variable, divide both sides by pi to get this by itself, and we end up with 30 centimeters equals the diameter. No problem. And we also have an equation for area. Our equation for area is going to be pi r squared. And so we can find the area of a circle that has a diameter of 10. We need an a, we need an r to use this. We don't have the a, that's what we need to find. So we'll leave that as a, and then our radius is going to be 5, because we divide the 10 by 2 to get 5 squared. So we have a, 5 squared is 25. We'll just put that first, right? And we can plug in 3.14 for pi if we want, or we'll just leave it like this for the sake of simplicity. And the units for area are feet squared, because we are counting the number of squares inside of the shape technically, so 25 pi. We can also find the radius if we're given the area, right? It's just backwards. Okay, we're still using the area equation, so just write that down. Does it give us the a? It does give us area, 9 pi. We plug that into the a spot this time, times pi. We need to find the r, so we're going to leave that as r. Now we want to solve for the r. We divide both sides by pi. 9 equals r squared, and then to get the r by itself, we square root both sides, and we get 3 feet equals the radius. No problem. And so we are doing a variation of the area and the circumference called arc length and sector area. So arc length is going to be a portion of the circumference, just this part right here. It's kind of like the crust of a pizza. Okay, instead of finding the entire crust, it's just the crust of one slice. So the arc length is the length of an arc, but it's just a portion or fraction of the entire circumference, right? So since this is a portion of the circumference, we actually are going to use part of the circumference equation, right? So part of our circumference equation is pi times diameter, right? But since we just want a portion of it, a fraction of it, we're going to take that circumference and we have to multiply that by pi over 360, right? Oh, I'm sorry, that's not pi, that's theta over 360, right? So theta is this angle, and remember there are 360 degrees in an entire circle, right? So this just represents this little fraction. Okay, so we're just going to do the first full circumference and multiply it by that fraction to get this. Okay, so let's go ahead and go to these two examples. We are going to find the arc length, this length right here. Okay, and our diameter is 10 feet, and this is 150 degrees. So we need these, this, and the theta. So we need to find the arc length, so we'll just leave that as AL. Pi, as it gives us the diameter of 10. There you go. And then we have 150 over 360 to get the fraction that we're multiplying it by. Okay, so we'll rearrange this a little bit, just look a little nice. We'll put the 10 before the pi. Now we can simplify this before just writing that. We'll divide both sides by 10, make that go away, 15 over 36, and then we'll divide that by 3, divide that by 3, so we'll get 5 over 12. So we have 10 pi times 5 over 12. Remember to multiply this number with this fraction, you just put it over 1. 10 times 5 is going to be 50. 1 times 12 is going to be 12. We'll put the pi after that. Divide this by 2. Divide this by 2. We simplify this, and we get 25 over 6 pi. And we could plug in 3.14 to get the exact answer, but we'll just leave it like this. We don't have to do an extra step. And since this is arc length, it's 25 over 6 pi feet. So that's how long this portion is. Okay, so let's just do another one. Same thing, we need to find the arc length, pi, our diameter. This time it gives us the radius, right? The only difference is to get the diameter, just multiply that by 2. So 4 times 2 is 8. And then we have pi over 360, 90 over 360. Once again, we'll write the 8 before the pi, simplify this a little bit before writing it down. 9 over 36 simplifies to 1 over 4. Make this into a fraction. 8 times 1 is 8. 1 times 4 is 4 pi, which gives us 2 pi feet. So that portion of that crust is 2 pi feet. And now we have sector area. And I'm sure you guys would be able to guess what the sector area is. It's just going to be the area of a sector or the section. So instead of getting the entire area, it's just the area of this slice of pizza, right? So it's like a slice of pizza. It's like the cheese part or everything part, right? So it's the area of a sector or section, but it's just a portion, fraction of that, right? So once again, we are going to use part of the area equation, which is pi r squared. But we don't want the entire circle. We're just going to multiply that by the portion of it, which is going to be theta over 360, right? So you're just shrinking it by multiplying it by the fraction. Okay, so let's do 2 more examples. These will be our last 2. So we want to find the sector area. So we want to find what this all is, area of that. So surface the sector area equals pi. Does it give us the radius? Yes, it does. 10 squared. And then we have theta over 360, 120 over 360. So 10 squared is 100 pi. 120 over 360 divided by 10. 12 over 360 reduces to 1 over 3. And then we do the same thing. 100 times 1 is 100. 1 times 3 is 3. So it's going to be 100 over 3 pi feet, and since this is an area, it's going to be feet squared. So that is the area of this slice. Okay, and we'll do one last one. Surface area, sector area, I'm sorry. Our radius is 4. Our theta is 45 over 360. Follow the same process, 16 pi. Now we're multiplying that entire area by the little fraction part. 45 over 360, you can divide the top and bottom by 45, and we get 1 over 8. Follow the same process, and we get 2 pi centimeters squared for that slice. Thank you for listening.